Hello everyone. I'm sorry electricity went out. Everyone is there?
Yes, sir. Still here.
Yes, sir.
All right. I hope it's okay, right? Free electricity in New Delhi. So things happen. All right, you guys noted down this question?
Yes, sir.
All right, so let's move on. So this is all about differentiability. Let's understand why LHD we got that formula. The theorem. Suppose I draw a graph like this. Sahel, you are there?
Yes, I'm there.
All right. Suppose this is a point C. This is C minus H. And this is C plus H. All right. So this coordinate I can write C comma f of C. This coordinate I can write C minus H comma f of C minus H. This coordinate is C plus H comma f of C plus H. Everyone is clear about this? X coordinate comma Y coordinate, right?
Yes, sir.
Yes or no? All right. Suppose I draw this line. This is point A, this is B, this is C. Or let's make it D because we already have C. Suppose I join this line BD and AB. So AB is a line. Does anyone remember the slope of a line? What is the formula for slope of a line?
Y is equal to mx.
No, that is the equation of a line in slope form, right?
Y2 minus Y1 divided by X2 minus
Yes,
X.
absolutely right. So if I have to write the slope of a line AB here, so Y2 minus Y1, I can write f of C minus H minus f of C upon C minus H minus C. Yes or no?
We could write the either way around, right?
Yes, you can write either way around. No worries. All right. Same way we can write slope of line BD. We can write what? F of C plus H minus f of C upon C plus H minus C. Yes or no? This is the slope formula y2 minus y1 upon x2 minus x1. Pinza, Aman, Sahel, this is clear?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Now imagine I shift this A closer to B. All right. This point I am making this move to the right side. All right. So this line, what will happen to this line? Suppose A is here, B is here. This is the line. Then A will come to here. This is the line. And as soon as A comes really close to B, then this line AB will become the tangent at B. Yes or no? This thing is clear to everyone?
Could you repeat, sir?
Yes. Suppose this is the point and this is the point. If I draw like this is the line. If the point becomes closer, then the line becomes like this. Right, Sahel?
Right, sir.
So if 2 points are very close, one point is here, one point is very close. And if you join a line by making these two join, then the line will become a tangent. Yes or no? How do you draw a tangent? You draw 2 points really close, join them. Yes or no?
Yes, sir.
Right. So if I move this A very close to C or B, then this line AB becomes tangent at B. Same thing happens if I move this point D towards B. Everyone is clear about this? Yes or no? No, Aman, Kinza?
No, sir.
How to explain? Suppose the points are very far. All right. Let me get some equipment, straight lines. If I join these two, this is the line we get, right, Kinza?
Yes, sir.
Now let's move this A towards B on the curve, right? So now this line becomes like this. If I move a little bit more close, then this becomes like this. So you can see the distance between this curve and this line is becoming less and less, right? The line
Yes,
is
sir.
shifting upwards. So if I draw A here, this line becomes like, so look at the distance, right? Very small compared to this.
Yes, sir.
Now suppose A is here, so you cannot even comprehend, right? Almost matching to the curve.
Yes, sir.
Now suppose A is here, just the next point of B. So if I draw a line now, this will go like this outside the curve. Yes or no?
Yes, sir.
And what is a tangent? A tangent is just this, which just touches the graph and moves on.
Yes,
Right?
sir.
So can I say if A is really close to B, this is the next point of B, then this line AB will become the tangent? Yes or no?
Yes, sir.
So this is what I'm saying. If I move this point A, yes, this point A to C, then this line AB becomes tangent at B. Yes, this is clear now.
Yes, sir.
All right, Aman, clear?
Yes, sir. It's clear now.
All right. So now I can say if how would that, if I make this H very small, then there will be no difference between C and C minus H. So how to make things very small? We use limits. So if I write limit H tending to 0 and write the same function f of C minus H minus f of C, and this thing becomes C minus H minus C is minus H, and H is tending to 0. So this is the tangent, slope of tangent at B. All right. Yes or no?
Yes, sir.
And if I do this to the point D, then I'll write limit H tending to 0 f of C plus H minus f of C, and this is plus H. This will be also slope of tangent at B. This thing is LHD. This thing is RHD. All right.
Yes, sir.
So what we say is differentiable when this happens, that LHD equals to RHD. Then what does it mean? There is a unique tangent at B. Right. This is the meaning of differentiability, that there exists a unique tangent at point B if at point B function is differentiable. This thing is clear. Why? Slope of this line and this line is equal, and we all know that a line from a specific point with a specific slope, only one line is possible. We cannot dot two lines, right? What I'm saying, everyone is understanding or going above the head?
No, sir. It's making sense.
Understanding, sir.
All right then. Please write it down. From here, you can draw the graph also in your own words. You can write, just write this one clearly. Right. So if LHT equals to RHT, function is differentiable and unique tangent at B. Sahel, this is clear?
Yes. Yes, sir. I'll just note it down.
All right.
Minimize it, sir. So
Done, sir.
All right. So there are few points we should know. First, you can write useful information. If a function is differentiable, at a point C, then it is also continuous at C. All right, but converse is not true. It's not necessarily true. Right? What does this mean? See, basically what continuity checks is if there are some broken parts in a graph. If it is not broken, then function is continuous. All right. If there is not broken, this graph is not broken, this is continuous. This graph is not broken, this is continuous. All right. This graph is not, and this is continuous. If it is broken, this is not continuous. But what differentiability checks? the smoothness of the graph. All right, this is a very smooth graph. This is differentiable, but you can see here this point, this point, this point, this has sharp corners, right? Everyone, corner points. So this is not very smooth. So at these points, graph will not be differentiable, but this is continuous, right? And we can see that if this is differentiable, this is continuous also. But in the second example, function is continuous, but not necessarily differentiable. Every rectangle is a quadrilateral, but every quadrilateral is not a rectangle. This thing is clear, what I'm saying? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Note it down. Second point, if a function is not continuous at C, then it is not differentiable also.
Sir, can you read the first one?
Function is differentiable at a point C, then it is also continuous at C, but converse is not necessarily true. All right.
Yes, sir. Thanks.
And in the second one, what they are saying, if the graph is broken itself, then obviously this is not differentiable. How are we going to say this is smooth? Right? Broken things are not smooth. So if a function is not continuous at a point C, then it is not differentiable also. Note it down. All right. Last point on this. Function is non-differentiable at C, then C comma f of C is either a corner point or discontinuous at C. F is discontinuous at C. All right. So what this basically means is there can be two reasons for a graph to be not differentiable at C. This can either be a corner point, right? I told you what a corner point is, where the graph is not moving smoothly, sharp corner, or this is discontinuous, broken point. All right. So note it down. You can get 1 mark questions out of this. Done, everyone?
Yes, sir.
All right. So now it's a test time. Give me 2 minutes. I'll be sharing the test paper with you. All right. Aman, Sahel, done?
Yes, sir.
All right. Just give me 2 minutes. All right. Everyone see the paper?
Yes, sir.
All right. So there is some changes. This question is not part of the paper. All right. Out of this 5, do any 3. All right.
Okay, sir.
Yes, sir.
All right. So you have 30 minutes